Let's look at the next example. Limit at infinity. We stay with natural log, but this time natural log divided by the cube root of x. So unlike e to the x over x squared, these functions grow, both functions grow very slowly. The natural log of infinity will go to infinity, and also the cube root of infinity will go to infinity, but not as nearly as fast as e to the x and x squared. So it's still infinity over infinity, therefore this rational function is qualified for L'Hopital. And let's keep in mind that the cube root of x is x to the power of 1 over 3. Okay, so if you take the derivative of the natural log of x is 1 over x. The derivative of the cube root of x, or the derivative of x to the 1 over 3, is 1 over 3 x to the negative 2/3, like so. So this looks a little bit more involved. But it's not too bad. Let's rearrange it. It's all about the algebra part here. So 1 over x, x will drop to the denominator, but we have 1/3 in the denominator, and the 3, if you instead of dividing by a fraction, you multiply by the reciprocal, so you multiply by 3, 3 migrates to the numerator. So 3 migrates to the numerator, x from 1 over x will migrate to the denominator, and you'll end up having 3 divided by x times x to the negative 2/3. When you multiply these two power functions, you end up having x to the 1/3, or the cube root of x. So you end up having 3 over the cube root of x. Again, x to the power of 1 times x to the negative 2/3 gives you x to the 1/3, or the cube root of x. And now we can do direct substitution. We have 3 divided by infinity. Even though it's a cube root of infinity, it's still infinity. And if you have infinity in the denominator, then you end up having 0. Couple of trigonometric functions. The first one is a little bit tricky, and you probably wouldn't know how to do it until I show you a little trick or two. Okay? Well, let's look at it. Okay, the function goes like this. We are number 7, right? We look at the limit as x goes to 0 of tangent x minus x divided by x squared. I'm sorry, x cubed. Okay, so I'm looking at it. First, let's verify that we qualified for L'Hopital. Tangent of 0 is 0, so 0 minus 0 is still 0, and you have 0 divided by 0, so this is qualified for L'Hopital. Okay, so my claim is it's qualified for L'Hopital, and therefore I'll take the derivative. Well, we know the derivative of the tangent is the secant squared, and the derivative of x is 1, and the derivative of x cubed is 3x squared. So I'm looking at secant squared x minus 1, and I'm looking for a way to simplify it. And look at the 3 Pythagorean identities, and you can see that secant squared by itself is tangent x it's 1 plus tangent x squared. Okay, so if you substitute secant squared is 1 plus tangent squared, okay, then this will simplify somewhat. You have 1 plus tangent squared minus 1, so you end up having the limit as x goes to 0 of tangent squared divided by 3x squared. We are not out of the woods yet because I still have 0 over 0, right? So once again, we'll continue to apply L'Hopital. We are qualified, 0 over 0, and now I need to take the derivative of tangent squared. So let's say tangent is u, and we'll do the chain rule. The derivative of u squared is 2u times the u dx, or in this case it'll be 2 tangent x, and the derivative of the tangent is secant squared. The denominator, the derivative of 3x squared will be 6x. And here comes not really the trick, but the smart part of this exercise. We start by first simplifying 2 over 6 is 1/3. I can yank it outside the limit. It's a constant, so it doesn't change. And now what I see that I have secant squared and I have the tangent x over x. Now, one thing you can observe that the secant of 0 is 1, right? Secant is 1 over cosine of 0 is 1, 1 over 1 is 1. So the limit of the secant squared when x goes to 0 is 1. And I know that the limit of a product is the product of the limit. So I'm going to break it down, this quantity. I took care of the 2 over 6, and now I'll write it as the limit of secant squared as x goes to 0 times the limit as x goes to 0 of tangent x over x. Okay? So what I did, I applied the limit rule that says that the limit of a product is the product of the limits. The advantage is the following. This limit right there, the limit of when x goes to 0 of secant squared, I can do direct substitution. Secant of 0 is 1, so this quantity, this limit is 1. So the result is that I have 1 over 3 times 1, and then I need to deal with the limit as x goes to 0 of tangent x over x. Am I qualified for L'Hopital? Hell yes, I am. I have tangent of 0 divided by 0, right? So it's qualified for L'Hopital. So again, I'll write it like so. It will be 1/3 limit, and now I'll take the derivative. The tangent is the secant squared, the derivative of the tangent. The derivative of x is 1, so I have the limit 1/3 the limit as x goes to 0 of secant, but this is simply 1, so I have 1/3 times 1, and the result of the limit is 1/3. Give me a little wow here. Whistling.